Hi, my name is Nicholas Francis. I'm a junior in Geospatial Science here at Radford University, and I'd like to welcome you to my presentation on animal collisions in Virginia national forests and parks. Deer crossing the road can be immensely dangerous to motorists, as the collision can cause serious damage to the vehicle, as well as put the driver and any passengers at risk of injury. Learning reasons for the movement of these animals across roadways can be crucial in planning for and learning how to mitigate these dangerous occurrences in the future. As the project progressed, the research went through a series of analyses in an effort to understand possible reasons for these deer crossing the roadways. There are two hypotheses that were tested in this project, the first of which estimated that the number of collisions were directly related to the level of habitat fragmentation due to roadway corridors and transmission power line rights-of-way. The second was concerned with the area of the fragmented habitat and how that correlated with the number of collisions around each habitat. Now, the data for this project were retrieved from a series of online sources listed in the bottom right corner of this poster, and most of these data were at a national level, so they needed to be trimmed down to be able to be worked with for just the three study areas. The fragmentation corridors were also added together and overlaid onto the forested areas to provide a layer of barriers to fragment the habitats. Information such as the number of fragmented habitat pieces and the area of each of these pieces were pulled for analysis. Collision data were also overlaid, and a process was run to determine how many collisions happened around each habitat. The first portion of the results show, as you can see in the chart, that the number of fragmented habitats, or increased fragmentation, leads to increased vehicle collisions, supporting the first hypothesis of the research. As you can see in this chart down on the bottom, Jefferson National Forest had a total of 108 fragmented areas, which accounted for 1,200 collisions between 2013 and 2020. Now, in a similar pattern for George Washington National Forest, there were a total of 68 different fragmented habitat areas that led to about 912 collisions, again, between 2013 and 2020. Now, Shenandoah National Park is a much smaller area, but it showed a very similar pattern where the 8 fragmented areas accounted for 29 separate collisions. In this graph, we can see that there's a weak positive correlation between the habitat area as well as the number of collisions per habitat. This result does not support the second hypothesis. In fact, the second hypothesis was predicted to be almost exactly the opposite, where the area of the habitat was inversely related to the number of collisions around that habitat. The final test that was done was a one-way ANOVA to test the similarity of means for the number of collisions and habitat area in the two large forested areas, George Washington National Forest and Jefferson National Forest. Now, even though these forests are not the same size or fragmented in the same way, the results of the ANOVA indicate that there is no statistical difference between the national forests in terms of fragmented habitat area or collisions per area of these fragments. This concludes my presentation. I would like to say thank you to Dr. Manyara and Dr. Foy for helping out with this project, getting my ideas organized, as well as helping with the analysis and planning my different processes that needed to be done to get this project to where it is now. I'd also like to thank the Office of Undergraduate Research and Scholarship for setting up and managing this online platform to present our projects that we have all worked hard on. Thank you. Have a good day.